Hello, welcome back to Learn Physics. See, yesterday we finished the topic theory portions of electrostatics and electrostatic potential and capacitance. So today we are continuing with our numerical. Okay, so yesterday I didn't teach you any numerical. So some parallel plate capacitor, energy stored in a capacitor, grouping of capacitor, that and all we didn't do. So today we are going to do that numericals. Okay, so the first one is, what is the area of the plates of a 2 farad parallel plate air capacitor given that the separation between the plates is 0.5 centimeter? So what is the area of the plates? A is asked of a 2 farad parallel plate air capacitor. So C is equal to 2 farad and given that the separation between the plates is 0.5 centimeter. So 0.5 into 10 to the power minus 2 meter. We need to find out the area. How we can find out parallel plate air capacitor? It is given. So C is equal to epsilon 0 A by D. A we can find out by CD by epsilon 0. C is given 2, D is given 0.5 into 10 to the power minus 2, that is epsilon 0 is 8.854 into 10 to the power minus 12. So you can find out the final answer. Clear? So this is how we should find out the area. Next one is 2 parallel plate air capacitors have their plate areas 100 centimeter square, 100 and 500 centimeter square respectively. If they have the same charge and potential and the distance between the plates of first capacitor is 0.5 millimeter. What is the distance between the plates of the second capacitor? So here two parallel plate capacitors, their areas are given as A1 equals 100 centimeter square and A2 equals 500 centimeter square. Okay, then we should, if they have the same charge and potential and distance between the plates of first capacitor is 0.5 millimeter. So D is given as 0.5 millimeter. Okay, so we need to find out distance between the plates of the second capacitor. So how we can find out if they have same charge and potential? So charge is same, Q1 equals Q2 and potential V1 equals V2. Okay, Q and V are same means then we can write down at C1 will be equal to C2, isn't it? C is equal to Q by V. If C1 is equal to C2, then we can write it as epsilon 0 A1 by D1 will be equal to epsilon 0 A2 by D2. So epsilon 0 will get cancelled. We can write it as A1 is 100 into 10 to the power minus 4 divided by D1. This is D1 0.5 into 10 to the power minus 3, that is equal to A2 as 500 into 10 to the power minus 4 divided by D2. So you can find out D2. See here, D2 will be equal to 0.5 into 5 into 10 to the power minus 3. So we will get it as 2.5 millimeter. Clear? Next one is a previous year question, that is 2 capacitors of capacitance of 6 microfarad and 12 microfarad are connected in series with a battery. The voltage across the 6 microfarad capacitor is 2 volt. Compute the total battery voltage. 2 capacitors of capacitance, C1 is equal to 6 microfarad and the other C2 will be equal to 12 microfarad. These are connected in series. Okay, then with a battery. The voltage across 6 microfarad capacitor is, so this is C1 and this is C2. It is connected across a battery having voltage 2 volt. This is 6 microfarad and this is 12 microfarad. See, voltage across this one 6 microfarad is given as 2 volt. Okay, so we should find out the total battery voltage. Okay, so So here we should find out the total battery voltage, how much we need to find out. See, C1 is given as 6 microfarad, that is 6 into 10 to the power minus 6 farad, and V1 that is equal to 2 volt. Then we can find out Q1, right? Q equals CV, C1 V1. So 2 into 6 into 10 to the power minus 6, that is equal to 12 into 10 to the power minus 6 coulomb. Okay, since both are in series, which will be constant? Q will be constant over there. Q is constant. So for the second capacitor C2, 12 into 10 to the power minus 6 farad, Q2 also will be equal to same, since they are having the same, they are in series. So if we are connecting the resistors, we will say current is same. Here, since it is capacitors, we will say charge is same. So Q2 is same, 12 into 10 to the power minus 6 coulomb. C2 equals, how we can find out? V2 only we need to find out, right? So V2, how we can find out? V2 will be equal to Q2 by C. C2, so since both are same, we will get it as 1 volt. So total voltage will be V1 plus V2. V1 already we got it as 2 and this is 1. So the total voltage will be equal to 3 volt. So in this question you should understand that in series connection, charges in series connection of the capacitors, charge will be same. In parallel connection of the capacitors, voltage will remain the same. Clear? So here find the charge appearing on each of the 3 capacitors as shown in figure. So we should find out the charge on each capacitor A, B and C. We have the voltage with us, each capacitance also we have. And these two are in parallel and this is in series with the parallel connection. So if I am considering this one, first B and C are in parallel. B and C are parallel. If it is parallel connection, what will be the effective capacitance? C1 plus C2. So we will get it as 8 microfarad. C1 plus C2, 8 microfarad. So I am redrawing this as here. This is B and C together, it became CS, CP now, that is equal to 8 microfarad. Here it is 8 microfarad. Now this A and this CP are in series with each other. Okay, now A and CP are in series connection. So same charge only flowing through this one, right? So they will be in series. So here series connection 1 by CS will be equal to 1 by C1 plus 1 by C2. So 1 by 8 plus 1 by 8. So we will get it as 2 by 8. CS will be equal to 4 microfarad. Okay, so the total connection, the total capacitance we got it as 4 microfarad. So what will be the total charge? Total charge will be equal to Q equals C into V. So we can write it as CS into V. What is CS? 4 into 10 to the power minus 6 into 12. So 48 microcoulomb. So this is the total charge. Those total charge fully it will be moving through this 8 microfarad. Right, it is no splitting over here, and here while we are comparing B and C, both are of same capacitor, so charge will be equally divided between them, because since its charge capacitors are same. Okay, so charge flowing through A will be equal to 48 microcoulomb and charge flowing through B is equal to 24 microcoulomb and through C will be equal to 24 microcoulomb. Clear? So both the charges, both the capacitors are same. Since these two capacitors are same charge will be flowing through B and C. Clear how we are finding out? First you need to do the this in effect charge. What is the total charge and how it will be splitting among each other. Clear? Next is find the capacitance of the combinations between A and B. So here A and B are not marked. So this is A and this is B. So first you should consider from one end. So I am considering starting from here. So if see the charge is moving like this. Okay. The charge is moving like this. Suppose if the charge is moving like this, same charge will be moving through this 2 also, 2 microfarad. So these two are in. I am considering this as 1, this 2, this 3, and this one as 4, and this one as 5, this one 6, this one 7, and this one as 8. Now 1 and 2 are in series. Okay, if they are in series, 1 by Cs is equal to 1 by C1 plus 1 by C2. Right, so it is equal to 1 by 2 plus 1 by 2. Okay, so it is equal to 1. So Cs we got it as 1 microfarad. Now instead of this 1 and 2, I can 2 and 2, this one I can write it as 1 microfarad, and that 1 microfarad is in parallel with the third one. This is Cs and this is 1 microfarad. Okay, now the Cs and 1 microfarad are in parallel. So we will get it as Cp equals 1 plus 1, that is equal to 2. So till here we are getting it as 2. Then that 2 and this 2 again in series. If 2 and 2 are in series, what we will be getting? Again 1 we will be. So first we should consider these two. These two while we are considering, we got it as 1 microfarad. And along with this we will get it as 2. Then that 2 and this 2 are again in series. So again we will be getting it as 1 microfarad. Okay, so again we will get this as 1 microfarad. Okay, then again this one we will get it as 1 microfarad. So what will be the total effective capacitance? Effective capacitance will be 1 microfarad, because this is 2. Okay, this 2 and this 1 will again become 2, and this will become 1 microfarad. This again will become 1 microfarad. This one again will become 1 microfarad. Clear? So what will be the final answer? Final effective capacitance will be equal to 1 microfarad. 1 microfarad. Clear? Next question is, a network of 4 10 microfarad capacitors are connected to a 500 volt supply as shown in figure. Determine the equivalent capacitance of the network and the charge on each capacitor. So the capacitors are given like this, 4 capacitors. It is given in this manner. Each are 4 microfarad. So here it is C1, this is C2, and this is C3, and this is C4. Here A, B, C, and this one is given as D. Here the voltage across it is 500 volt, and each one is 10 microfarad. We need to find out the equivalent capacitance. Each one is 10 microfarad. Okay, C1 equals, C2 equals, C3 equals, C4 equals 10 microfarad. We need to find out the equivalent capacitance. So this is 10 volts applied over here. So here everything, this is positive, this is negative, positive, negative, positive, negative. This is negative and this is positive. So here it is positive terminal and this is the negative terminal. Now effective capacitance. So charge, same charge is moving across this one till here. So C1, C2, C3, same charge. Here only potential is given, right? So C1, C2, C3 are in series, same charge. C1, C2 and C3 in series. So how we can find out? 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So everything is 10 microfarad. So we will get it as 3 by 10 microfarad. Cs is equal to 10 by 3 microfarad. Okay. Then this Cs and C4 are in See, instead of this CS, what we can draw? Now we can draw like this is 1 CS and here 1 C4 is there. Here 500 volt is given. 500 volt. Okay, so C4 and CS are in parallel. Both are in parallel. Parallel connection means CP will be equal to CS plus C4. So we will get it as 10 by 3 plus then again 10. So we will get it as 40 divided by 3 microfarad. Now we need to find out the charge on each capacitor. How we can find out? See, C1, C2, C3 are in series. Since they are in series, we can write Q1 will be equal to Q2 will be equal to Q3. Okay, so how we can find out the potential? See, potential across C1, C2, C3. That series connection will be equal to the potential across CV. But the same charge is flowing through this. The potential across C1 plus C2 plus C3 is equal to 500 volt. So V1 plus V2 plus V3, that is equal to 500. So what is V1? V equals Q by C. Q divided by C1 plus Q by C2 plus Q by C3, that is equal to 500. So here we will get it as, see, Q we can take it common, 1 by, what is the value? 10 plus 1 by 10 plus 1 by 10 equals 500. So here Q equals, here 3 by 10 we will get Q into 3 by 10 equals 500. Therefore Q we will get it as 5000 divided by 3. This will be microcoulomb. This will be the charge on each capacitor, 500 microcoulomb. Now we need to find out the charge across this C4. C4 charge, how we can find out? C4 value is given. What is that? It is 10 microfarad. So total is 500. Q equals C into V. 500 into 10 microfarad will give you the charge on this C4. Okay, Q into C4 will give you the final answer. Okay, so this one, each one will be having 500 divided by 3 or 5 by 3 into 10 to the power 3 microfarad. Microcoulomb charges are there in C1, C2 and C3. In C4 alone, how much charge we will be having? We will be having Q into CV. Q equals CV. So Q equal C4 into 500 will give you the charge. Clear? Next one, two capacitors of capacitances 3 microfarad, 6 microfarad are charged to potentials 2 volt and 5 volt respectively. These two charged capacitors are connected in series. Find the potential across each of the capacitors. This is also a previous year sample question paper. Okay. Here two capacitors, 3 microfarad and this is 6 microfarad. Before connecting, this 3 microfarad is having given a potential of 2 volt and this has given a potential of 5 volt. Okay, so we need to find out if they are connected in series, what will be the potential across each capacitors if they are connected in series. Now it is given a 2 volt potential, 3 microfarad has. So what will be the charge in that? Q1 will be equal to C1 into V1. This one I am taking as C1 and this one C2. So here we will get it as 6 microcoulomb and Q2 I will get it as C2 into V, 30 microcoulomb. So while they are connecting in series, what will happen? Charges will be conserved, right? So total charge will be equal to Q1 plus Q2, that is equal to 36 microcoulomb. Clear? So this is the total charge in the capacitor. Q1 plus Q2, that is 36 microcoulomb. Now we can consider, we should find out if they are connected in series, what will be the potential on each capacitor. Now it is connected in series. Okay, so while we are connected in series, here 36 microcoulomb, this is the total charge 36 microcoulomb of charge is given across 3 microfarad and this is given across 6 microfarad. So what will be the potential here? V1 and this will be V2 after connection. That one we need to find out. C equals Q by V. Okay. So V equals Q by C. Q is 36 into 10 to the power minus 6 divided by 3. That is equal to 12, 3 into 10 to the power minus 6. So 12 volt and V2 will be equal to 6 into 10 to the power minus 6 divided by 36. Okay, 36 into 10 to the power minus 6 divided by 6 into 10 to the power minus 6. The answer is 6 volt. Okay, clear? So this is how we will be finding out. So this is before connecting, it was getting a total charge of 36 microcoulomb. That 36 microcoulomb is applied to these two capacitors. So how the potential is. So it is a sample question paper. It's important. Okay. So today some questions I will be giving as your homework questions. Please try to do that. And next day also I will be explaining those questions and extra questions also, because we didn't do for the energy of this capacitor, right? So that one we will do it in the next class. Okay, clear? So I think this is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.